have myself, Teresa Nelson, stormwater engineer with the division, as well as Casey Coconati, Jess Starks, and Jim Neidhart, who are some of our site erosion control inspectors. And behind the scenes today, helping out with some of the technology and running the webinar is our colleague, Elliot Morgan. So to give you a little information about the webinar today, as you may have noticed, you do not have the ability to talk or show your video with as many people we have on. We decided to not allow that, but questions can be asked through the Q&A, which is a button at the bottom of your screen. And that can be, you can ask questions through that at any time during the presentation. We will be leaving about 15 minutes at the end today to answer questions. So, please make sure you have some for us. We are offering a PDH for this presentation, and those will be emailed out after the webinar. If you happen to be joining and you didn't actually sign up and register, so we don't have your email, please send us a message. We'll have an email address at the end of the presentation that you can email and let us know that you attended. And with that, we are first going to start out with a poll. And it is, how confident are you in filling out the USLE? So your choices are, what's a USLE? I need quite a bit of assistance. I might need help from time to time, or I've totally got this. All right, and our answers. So there's a bit of variation here, but it looks like most of you are pretty confident, which is good. A few have said, what's a USLE? So we will start out with some background. So thanks for doing that. So our outline today, we're going to be, again, going over some of the background of the USLE and then getting into some of the model specifics. And really the point of today is to share information, especially that's specific to Dane County and what we're looking for in submissions. We'll be going over some case studies and examples. And like I said, we'll be leaving about 15 minutes at the end for questions. And again, you can use the Q&A section to ask questions. And really our goal for today is for you to understand, what we are looking for as county staff when USLE calculations are submitted for erosion control permit applications. So what is the USLE? It stands for Universal Soil Loss Equation, and it was developed almost 60 years ago for estimating soil loss on agricultural fields. It's a planning tool to limit soil loss from sheet and rill erosion. So that's really important. This is looking at areas where there's sheet flow across the land, and it's not appropriate for areas where there is concentrated or channelized flow. And it was designed as a simple and quick equation that's based on rainfall, soil texture, topography, and management. And here in Wisconsin, we modified that equation for use on construction sites about 10 years ago. And this is something that's used by both the Wisconsin DNR and Dane County. And I'm sure many of you know that the county had our own separate spreadsheet for calculating the USLE up until our recent ordinance amendment. So last fall, we updated our ordinance to change our requirements, and now we are expecting the use of the DNR spreadsheet. So why we use the USLE? Well, research shows that construction sites on average can contribute approximately 30 tons per acre per year of sediment to local waterways. And obviously this can negatively impact aquatic plants and animals. So using this calculation, we can get at a numeric goal for reducing sediment discharge from construction sites. Like I said, this is written into our county ordinance as a performance standard that must be met for all erosion control permitted projects. We do use the dates that are listed in the USLE for our permit expiration. So when in the USLE, the date for restoration is specified, and there will be no more soil erosion after that. That's the date that we use for the expiration of our erosion control permits. And really ultimately it comes down to, we use this so that we can protect downstream water quality. So some resources. So we're talking about a Microsoft Excel spreadsheet that's used to calculate the USLE, and that can be downloaded from the DNR website. And Elliot's going to copy these links into the chat for you to see and copy from there. There's also a DNR guidance document on that same page that is very useful. They go through a lot of the things that we're going to talk about today. But I will also then point out that Dane County has our own specific guidance on our Dane County wiki. It used to be our erosion control and stormwater management manual. It's now in a wiki form online, easy to search, easy for us to update. So I encourage you to look at both of those, because places where the Dane County guidance may differ from the DNRs, for our submittals, we would obviously be looking for you to follow the Dane County guidance. And this is a good opportunity to mention that, you know, we are all here to answer questions as well. So if you come up with something and you know, it's different, you're not sure which guidance to follow, give us a call and ask us the question. And finally, you know, if you're in the middle of things and you still have questions, the spreadsheet has this nice little help page where a lot of information is put here. So you can always reference back to this help page as well. And now I'm going to pass it off to Casey to get into some of the details. Casey, you're muted.
Perfect. Hi. So I'm going to start with a breakdown of the spreadsheet. We're going to go over each of the columns individually fairly quickly and then discuss some of them in detail a little bit more. So there we go. Okay, so the first one is the activity column. This is a drop-down box where you're going to specify the type of activity that's going to take place on the land. Bare ground is usually your first, likely your second. We have options for seed and mulch, seeding, and then an end date. Number 2 is the begin date. This is something you're going to have to enter based on your construction schedule. The end date, this one will autofill based on the next begin date activity that you enter. The period %R, this is a percentage of the annual rainfall factor that's calculated for that specified portion of the year. This is based off of the begin and end dates that you've entered. And that auto calculates, so you won't have to enter that. The annual R factor, again, this is auto-filled and it's based on the county. There's a drop-down box to select the county you're in when you're filling out this tool at the beginning. The rainfall factor is the number of erosive index units in a normal year's rain. The erosion index is a measure of the erosive force of a specific rainfall. And for Dane County, that's 150. So that'll auto-populate there and you'll see the 150. Moving on to number 6, this is the subsoil texture. So this is just going to be the soil type at the exposed surface. We're not looking at topsoil here. And you can find this information in the web soil survey, or you could put silt loam. That's the most erosive soil type. So we can assume that if the USLE meets the soil loss requirements with silt loam, it would meet it for any other soil type. The soil erodibility K factor, this is based on the soil type. You won't enter this, it will auto-populate. Number 8 is slope %, and number 9 is the slope length. These are both things that you'll be entering. You'll choose these based on the slope you've decided to model. And the % slope is just for the disturbed area that you're modeling. And then the length, this needs to be overland flow, not channelized. So You'll want to limit that length to areas where sheet and rill erosion will occur. The LS factor is going to be automatically calculated. This is just based on the previous 2% in slope length. The land cover, the C factor, this is based on the activity that you selected back on the dropdown for number 1. It refers to the management practice or the cover. So soil loss number 12 here, this is going to be basically some of those factors that have all been entered already. It will auto-populate and it breaks it down per activity time frame. And then on the bottom of the spreadsheet, you can see you get a total, but we're not done because we have the sediment deposition factor. And this factor alters the previously listed soil loss. It's based on an adjustment from Russell II and the USLE. It's varying slope lengths, soil types, and you can find all the details of this factor listed on that help page that Teresa mentioned earlier. The sediment control practice, this is a drop down that you'll be selecting as well. We'll go in depth on this later, but this is going to be a practice that would lower your soil loss yield. And lastly, the sediment discharge. This is the total number we're looking at. Through here, you can see it's broken down by time frame, and at the bottom, down here, you can see the total, and then you've got the % reduction required box. In order for us to be able to approve your permit, this has to say none. So now we are going to look at the activity box a little closer. So on the left side of your screen, we have the choices from the activity dropdown. We tried to categorize these to kind of give you an idea of when best to use them. The first one here is bare ground. We've listed that as land disturbance. This will likely be your first activity, maybe your second activity. It could be used whenever you're modeling a different slope. So after bare ground, a lot of times we'll see erosion mat, seeding, or land applied additive. We're considering these temporary measures. Directional tracking can be used as a velocity control. The erosion mat or mulch can be used as some surface protection, seeding as maybe a temporary seed, and land applied additive, we'd see you use it if you were applying a polymer. The final group, or the final stabilization group with seed and mulch and erosion mat or sod are 2 items that we would see as final stabilization. The exception here is you could use seed and mulch as a temporary measure, but we would not allow the other seeding or just mulch as final stabilization measures, which is why we left those 2 in separate groups. So the last one here is end, and that is when your site's established or when you're installing a hardscape. So concrete or pavement, you would use end as well. So this table I pulled directly from the help document, the DNR's guidance document. It kind of gives you an idea of the efficiency of these practices when you select them in the drop-down menu. So directional tracking or tillage, you get a 10% reduction from typical bare ground. Land applied additive is 50%, seeding is 60%, mulch or erosion mat is 80%, and then you can see mulch and erosion mat with seeding and sod, both above 90%. These are your final stabilization measures, and impervious surface is 100. If you wanted to indicate this on the DNR spreadsheet, you would just use end. We don't have paving listed in the drop-down box like the old spreadsheet did. So when we talk about stabilization, we want to make sure that we're timing it right. You can see the chart on the bottom. This is available on our wiki. It just gives you an idea of when seeding dates are recommended and when they're not. We have certain times of the year that seeding's not recommended just because you won't get germination within that 60 days. The issue with seeding close to these recommended seeding dates, but still outside of them, is the potential for germination and then frost kill. So if your project just can't be completed within these recommended seeding dates, there is the option to dormant seed. And when you put that in the USLE, you basically just move that end date to next spring, which I will show you here. So as you can see, the seed and mulch date on here was November 1st, which is outside of the recommended seeding date. So you just pull that end date. Instead of going 60 days out, you go out to May 15th of the following year. All right, so next we're going to show you a couple graphs here that give you a better idea of the period % R and the annual R factor. So this graph shows the monthly distribution of R and the annual percent. So you can see the middle of the graph, the steepest slopes there, July to September. This is the most erosive time of the year. This graph is very similar. We just changed it so that you can see the incremental percent along the y-axis. And you can see that the most erosive time of year is the first 2 weeks in July. So one thing to keep in mind is knowing this, if you have any flexibility in your schedule, having that area or having your bare ground temporarily stabilized, or not having the site open during those first few weeks of July can really give you the ability to keep the site open longer throughout the rest of the year. So now we're going to go into the sediment control practices, which are the drop downs on the right side of the USLE there. So I've got all of them listed here, and you can see that this table is the same as the last one. It's pulled straight from the help guide. You can see that sediment basins and sediment traps give you an 80% sediment removal efficiency. Silt fence is 40. The straw bale barrier is 40 as well. We've got this crossed out here because we really rarely see them installed properly, and so we just don't consider it an acceptable practice. We've got manufactured perimeter control and vegetative buffers also at 40%. Inlet protection gives you a 30% reduction, as well as the ditch check sediment trap. So the last few there, we rarely see as the practice that's specified on the USLE because people usually have other practices in place, but just know if you don't, those are options. You can use those as well. And in order to get this reduction, I want everyone to be aware that this means that this practice is installed, that the USLE slope or flow path you're modeling is going to these, and that they're maintained throughout construction. So I just saw the question pop up, so I'll answer it. Silt sock and silt fence can be interchangeable. You just have to make sure you're following the guidance, which if we go back here, follow the technical standard, you can reference that. So just a few notes on sediment traps and basins. We allow them to be used on the USLE. They give you an 80% reduction, which gives people a lot of wiggle with their schedules. So they need to be constructed to the proper size. They need to have an appropriate outlet. And we need to make sure that if the sediment trap is going to be used as an infiltration facility down the road, that they're protected from clogging. You can find details on all of this in the technical standard for sediment traps and sediment basins, but we just want to make sure that everyone remembers to put notes on the plans, because this really helps contractors and helps us as inspectors point these things out to the people who are building them on site. So this is an example of some good notes that we saw on a plan. You can see the red notes are just a continuation of the image above. Here you can see we've got that the culvert is to be plugged or removed during use of a temporary sediment trap. It's got elevations for bottoms, outlets, and then this bottom note just says basically that it will be installed prior to the rest of the mass grading on site. All right, we're going to talk a little bit about representative flow paths and how we would select those. We'll let Teresa dig into this later, but I'll give you an overview here. Typically, there are several potential slopes, combinations of practices, and you will probably have to model more than one in order to find what you're going to use. Probably the most important thing you need to look at right off the bat is make sure that your flow path is running perpendicular to your contours. We want these USLE slopes that you're modeling to actually show where water is going to go. You can and maybe will, like I said before, need to model more than one slope. So we want it to be representative of your site, but we also want it to be the worst case scenario. And this could look like maybe a long, shallow slope, maybe a short, steep slope. We usually see that a shorter, steeper slope produces a higher soil loss than a longer, more shallow slope. And you may also have these slopes change during grading. So the existing topography is usually only representative during the topsoil stripping phase. So like I mentioned earlier, you can have bare ground on the USLE for your first option, and you can have bare ground as your second activity as well. When you do this, you're able to change the slope and the slope length on the USLE to show that second slope that's more representative of the site through the rest of construction. The DNR guidance says not to worry about areas that are less than 10% of your site or less than an acre, but we would like people to still consider these areas. So just keep in mind that if you're submitting to Dane County, we would like you to look at all of the steep slopes too. And then when you fill these out and when you do this for yourself to try to find your representative slope, feel free to send us USLEs for multiple slopes. That way we know that you've done the work, you've looked into it. Otherwise, we likely are going to spend time checking ourselves. And then the last thing here is we want you to model slopes that are 3-to-1 or 33%. The DNR guidance spreadsheet says only to go up to 20%, but we would like to see those slopes that are a little bit steeper. After 33%, the spreadsheet breaks down and you really don't get much time to keep that slope open. So when you submit a USLE, we also want you to send a map showing us where this slope is on your plan. We want to see the existing and proposed contours, the erosion control and sediment control practices that you have, and the construction schedule. So here's an example of 2 USLE paths that are labeled on a map. We're showing this example because it's a good example. You can see the existing and proposed contours, and you can see those slopes. They've got it labeled with the slope length and the percent, and they are easily identifiable. So next we're going to talk about construction schedules. It's basically, we will look at your USLE as your construction schedule. Like Teresa said, Dane County permits expire on the stabilization date of a construction schedule. So it's important that they're realistic. Otherwise, we'll have to revise them, which is fine. But definitely communication with your contractors is important because a realistic schedule is much better than us going back and forth and revising these plans. And our goal here is not to shorten your construction time frame. This is your plan. We want you to be able to work and construct things in the time that it takes. Using the USLE is just helping us figure out how robust your erosion control measures need to be. So the last thing here is if your dates are unknown, you can go ahead and give us your best guess. One thing to do if you don't know exactly when a project's going to start is to probably give us at least a 3-week time from submittal. Sometimes we get plans that come in that are going to start tomorrow, and quite frankly, we probably won't get them reviewed by tomorrow. So we'll have to spend time doing a revision on the front end before the approval even is done. So typical turnaround time for the county is about 15 working days. So if your construction schedule is 15 days out, that's a great place to start. If you have a shorter project and you're not sure when it's going to actually happen, but you know it's this summer and you want to apply for your permit now, one option is to model that slope during the most erosive time period. And if it meets the soil loss requirement during those first few weeks in July, we can assume that it would meet the soil loss requirement during any other time throughout the year. So last, we're going to talk about the warnings that come up on the USLE. They very conveniently have put a lot of the warnings in red, so you should be able to notice them right away. The dates exceed 1 year. This warning means that your spreadsheet the time frame is more than a year. Each spreadsheet is only meant to model a 12-month consecutive period. So in this case, this means you would have to fill out 2 spreadsheets, a year 1 and a year 2, and we'll talk more about how to do that a little bit later. The second warning you can get is this slope over 20%. Again, this is fine. We want you still to model those slopes as long as they're under 3-to-1, but just keep in mind, you probably will have other erosion control or sediment control practices. And the next one is the cover establishment needs 60 days. So you'll see this if you have put seed and mulch and your end date isn't 60 days or more out. So all you have to do to fix that problem is move the end date out 60 days. And the last one here is the reduction required. So you can see under the sediment discharge, the total on this example here is 7.6, and that's a 34% reduction still needed. We can't approve a plan with a reduction needed. So you'll have to go back, revisit your slope length, sediment control practices, and see what you can do to get that back to none. With that, we are going to do a second poll. So the question here is, what do you think is the most challenging aspect of the USLE? Your choices are choosing representative flow paths, choosing appropriate orders of activities, representing your construction schedule, or meeting the soil loss requirement. All right, so it looks like the most difficult thing here is representing the construction schedule, followed by meeting the soil loss requirement. So luckily we have some case studies on these, and our next slide here. So we're gonna jump into the case studies. I'm gonna hand it back to Teresa, and we're gonna show you some USLEs, and hopefully you'll have a better understanding.
Thanks, Casey. So yeah, moving into our case study number one is just looking at picking representative slopes. So to kind of orient you to what this site is, you can see the gray lines are the existing topography, and the darker lines are the proposed topography. It's kind of, there's a kind of the top of a hill on the right side, and then it sort of splits and flow goes to the northwest and the southwest through this site. And so they chose 4 different slopes to kind of look at to represent different things that are going on this site, since there is a variety of slopes and slope lengths, both in the existing conditions and then the proposed conditions. So looking at our slope number one, so the blue line represents the existing conditions. So again, that condition that occurs when topsoil stripping is taking place, but the mass grading hasn't happened yet. And then the red lines are the condition once that mass grading is complete. So you'll see that they picked kind of the steepest part of that slope for the blue line. And then since that slope goes away during mass grading, they transition that into the red line. So that's the first USLE calculation that was done for this site. The next one is kind of on the other side of that slope. Again, not extending that initial conditions all the way through that slope, because you really want to pick the steepest part of that slope, not extend that flow path and then have kind of a lower average slope. You want to have a consistent slope with that slope length. The third one is what's occurring where the basins are being constructed. And then on the north side of the site, and then a similar one for the fourth calculation on the southwest portion of the site. So now just looking at what those spreadsheets look like, you'll see we have a first bare ground activity that uses the existing slope length, and then another followed by another bare ground activity that uses the proposed slope and slope length. And you'll see for this one, since the proposed final condition of this slope was to be paved and be buildings, they just put an end when that pavement was going in. Similar to the slope number 2, again, 2 bare ground activities followed by an end. This again is another place that was being paved and where buildings were being put in. That end could also be when the gravel is put down, when the base is put down, not necessarily waiting until the pavement, because gravel is considered a stabilization measure as well. Then the third slope, this is the one that's up where they're constructing those basins. And you can see that their second bare ground activity has that 33% slope. The back slope of those basins has a very steep slope. And you'll see that according to this calculation, they really could only allow that to be open for a few days. So this really shows the importance of looking at those steeper slopes. And sometimes it can control the management of certain locations. So it's not like you can't have the whole site open for only 3 days. It's saying that you have to look at this particular slope and make sure that it's restored, you know, in order to meet the soil loss requirements on that particular part of the site. And then similar to slope 4, this one only had a 25% slope for the proposed condition. But again, that slope wasn't allowed to be open very long. And one of the things, you know, with meeting the soil loss, you know, requirements for these, you know, sometimes you do either have to get creative with timing of that or changing maybe some slope breaks. We'll talk a little bit more about these things, but ultimately, meeting this soil loss requirement is part of your plan. And everything that's being proposed to meet this is something that even if we give you guidance, this is part of, you know, the plan that you're responsible for. And now I'm going to hand it back to Casey for our next case study.
All right. So the plan and USLE, I'm going to go over, I'm going to show you how this plan modeled grade changes. There's a few other things that I'll point out, but a little background on this site. This was an existing soybean field, and it was to be used as a fill site for a few years. So there's some temporary stabilization methods used too. You can see the long blue USLE flow path 1, that is the pre-existing conditions flow path. And the USLE 2 is the flow path for that same area once the fill has been placed. And then on the south end there, we have a third flow path, and that is an area that is open, seeded, open, kind of a moving part of this project. So here's the year 1 USLE. You can see the first bare ground activity in the beginning of August, and the second one at the end of August. So they've got that first flow path at 2% for 800 feet. That shows the pre-existing conditions. I want to point out too that they included a sediment trap as the practice here on the first line. A lot of times we don't see that because the sediment traps are not dug right away. For this project though, because it was an existing field, they went in and were able to dig the sediment trap right away. So they were able to use that for credit immediately. So the second bare ground date there in August, and then they've got a seed and mulch date. That's a temporary seed and mulch. They did apply both, so that's great. They can use that for that reduction. Like I mentioned before, you get about a 90% reduction. If you look at the soil loss for that activity time frame, it's pretty low. And then they opened the ground back up and started to haul out some of the fill in November. So that's what that next bare ground date is. And then again, the plan is that they're going to do another temporary seed and mulch in April, this coming April. And this spreadsheet, because they need the project open for 2 full years, they pulled that end date out. And year 2, next August, they plan to open it back up. I think this is the restoration phase of this project. They're going to work on making sure it's back to whatever grade they want it to be at. And the slope and length for this portion are all that third line at the bottom of the plan. The seed and mulch date is June 1st. And then the end date, 60 days out, you can see there is August 1st. So that's it for this case study. And I'm going to pass it off to Jess.
All right. So our third case study is hopefully you guys can hear me, project exceeding 12 months. For this example, we were wondering how it would work if your project's longer than 12 months. Used to be that we could show more than a year on the county USLE spreadsheet. For the DNR state guidance, the spreadsheet only is allowed for modeling 365 days. So a cumulative soil loss and sediment discharge amount for any consecutive 12-month period. So that's a very important thing to note. You know, for example, if we had an 18-month construction project, if that project was modeled at discharging 2 tons per acre in the first 6 months, 3 tons per acre in the second 6 months, and then another 3 tons in the final 6 months, then the project won't be in compliance because you're going over the 5 tons per acre per year. All right. Elliot, if you don't mind advancing that. So here's the sheet for year 1. We have a bare ground date of October 28th of 2020, and it's showing that rough grading with silt fence used as your BMP is there, and that is because, like Casey was saying, the sediment trap is not built yet. So you have your bare ground date of 10/28/20, and then you have another bare ground date of when you do have your sediment trap in place, December 28th of 2020. So for the year 1, what you need to do is take your bare ground date and add 365 days because you know you're going over a year. So the year 1 spreadsheet has an end date of your start date plus 365 days. So 1 year after that. And then next slide. Our year 2 is going to show you projecting the end date of 60 days during your growing season, and then your bare ground date beginning 1 year prior. So if you know that you're projecting the site is going to be fully stabilized with seed mulch or erosion mat on, let's say, May 5th of 22, you would take your end date of year 2, add 60 days, and this site is established. So as we talked about a little bit, established to us is the same as end. It means your site is either 70% vegetated, growing and green, or a fully installed hardscape surface. So the bottom line is, if you have a multiple year project, your year 2 bare ground date is your year 2 end date minus 1 year. And for the next case study, I will hand it off to Jim.
Hello, everyone. I'm going to take just a little bit of time here to talk about slope breaks, slope interruptions, and the benefit of doing so in order to meet your timeline. As you get familiar here with this site here, just as an overview, there's a barn that's being constructed at the top of a fill slope, and we've got 4-to-1 slopes. Those are the steepest slopes south of the barn, transitioning gradually to a 7-to-1 slope on the west side of the barn, and then back again to the 4-to-1 slopes up on the north side. So what the strategy here is going to be is to try to use slope breaks to provide sufficient amount of time, along with the steeper slope being the 4-to-1 slope, to make this possible for the duration that's necessary. I'm going to move to the next slide. Sorry about that. So the initial slope when we're stripping soil is the blue line, and that represents 185 feet at 11.4%. So we'd expect to see that in the first line of the USLE. And then you might be tempted to take the orange path that's being shown as representative, but really that's not the worst case. It's the 4-to-1 slope that extends from that southeast corner along the 4-to-1 slopes, perpendicular to those 4-to-1 slopes, and extending all the way down to the limits of disturbance, which is actually the worst case scenario. But there is a transition going, as stated before, where it goes from the 4-to-1 to the 7-to-1 slopes. So as we look at the USLEs here, we're able to come up with a strategy that will provide enough time You'll see here that the maximum length, slope length that would be allowable for those 4-to-1 slopes is 24 feet. So that's where you would potentially locate your slope break at 24 feet for the 4-to-1 slopes. But we also have the steeper slopes, or I'm sorry, the more gradual slopes to consider. So here's the 5-to-1 slope, 20%, and the maximum that you can have is 35 feet to manage and stay under that 5.0 total that's allowed. And then for the 7-to-1 slopes, you'll see that on the next slide, you can go as far as 81 feet without having exceeded the soil loss. So here you'll see the scenario that, that will work for this site. The slope breaks, silt logs are fine for that, being installed at a maximum distance of 24 feet south of the barn, and then gradually transitioning towards the 7-to-1, it extends out to 35 feet as you get more southwesterly to the westerly side. And so you've got these slope breaks being installed along that slope all the way down. And so this little trick here, I guess you might call it, would be something that can work for you to give you a little extra time. I also want to point out that because of the transition point from the proposed contours to the existing contours, there's kind of a swale that's being created where you'll have concentrated flow. So it makes sense then to extend the erosion matting out a little bit further. In this case, it's about 10 feet further out to handle that concentrated flow. And then also the silt fence was extended from that earlier slide that you might have noticed further out on both the east and the west sides. So I think that's pretty much all I needed to talk about for slope breaks. It's a nice tool and it does give you that additional time that you might need. And I think I'm handing it off to Teresa now.
Thanks, Jim. So just to kind of wrap up a few things here. So, you guys have said that meeting the soil loss requirement is one of the most difficult things with the USLE. So, looking at ways to reduce the duration of the bare soil, the time of year, the graphs that Casey showed with the sort of the rainfall erosivity in different parts of the year, that those first couple of weeks of July are going to be some of the toughest times, especially if you have steep slopes open during that time. You can consider phasing where maybe the whole site isn't open at the same time. That may help with limiting or reducing the soil loss from the site. As Jim just explained, the use of slope interruption to help with that. And also not to forget the temporary stabilization. I know this is not something that a lot of contractors like to do because sometimes it requires more than one mobilization of the landscape crew, but this is something that can be used to help extend that bare soil time of your site by temporarily stabilizing some of those steeper slopes. And in general, you're really going to have to target those most erosive areas, the steep slopes, the steep slopes with long slope lengths. So those are some tips to help you get to the point where you can meet that soil loss requirement. And then a few tips for efficient approval of these. Number one, make sure that your total is less than 5 tons per acre per year. We are not approving plans that are over that amount. And choosing representative slopes. We talked about how you may need to submit USLEs for more than one slope. Maybe it's just one slope that's really controlling for your site, but if you give us multiple slopes so that we can see and you lay it out in front of us that, yep, these look like they might be the worst ones, and yep, this is the one that kind of controls what needs to be done here, that really makes it more efficient for us to review, because then we don't have to look at it and say, well, that slope over here looks like that might be a little bit worse, or go back and ask you to do additional calculations. Including some of your kind of thought processes in the narrative is also very helpful. You know, if you've kind of, you know, thought through this and you looked at some things, you can write that into the narrative. Again, it helps us when we're reviewing. You can imagine, you know, we get in a plan and we have to orient ourselves to the site, what's going on, what you have planned. The more you can kind of explain it and explain your thought processes, the easier it is for us to understand. It's really important to include the map and label the map, the slopes on the map, label the slope and the slope length. Make sure that it's easy to correlate the lines on your map, your flow length lines on the map to the USLE spreadsheets. Again, all of this just helps make that review process a little bit more quick. And as Casey mentioned, you know, provide a realistic start date given our review time. Again, in general, we look to take up to 15 working days for review of plans as they come in. So with that, we'll do our final poll. And this one is, would you be interested in additional Dane County specific permitting tips webinars? So your choices are absolutely, yes, if there are PDHs available, or possibly, depends on the topic. And just to let you know that we will be asking for suggestions for topics. When you close down the webinar, it'll pop up with a screen that'll allow you to put in your suggestions for other potential topics for webinars. All right, appreciate the feedback on that. And now we will move, we have, about 15 minutes for questions. And so we'll all kind of get on here. I know Elliot's kind of been looking at the Q&A. I've been trying to look at the Q&A. I'll maybe just start out with a couple things, some common themes that I saw in the questions. And one of those was maximum flow length. So, there is guidance on, from TR 55 as far as sort of the maximum length that you would expect sheet flow to occur. We don't generally look at limiting it to that. It used to be 300 feet. Now it's more closer to 100 feet. Really, if the topography is not showing any kind of concentration of the flow, we would look to have longer flow lengths modeled in the USLE. And then the other one that I saw a lot of questions on was the maximum slope that we are asking you to model in the USLE spreadsheet. The DNR does limit that to 20%, and the county has decided per our guidance to move that up to 33%. When I said that the USLE was extended to construction sites about 10 years ago, our division manager, Jeremy Belusik, was part of that process. And through that process, he believes that the 33% is something that the USLE equation is well equipped to handle. And that's a policy choice that the county has chosen to take.
Yeah, and I guess this ties into a couple of questions that, are we going to do something to try to prevent any differences between the county's guidance and the state's guidance? And I don't think there is much difference beyond the maximum steepness that we allow in the USLE. Teresa, can you think of any other differences, I guess?
With the DNR guidance?
Yeah, DNR versus the county guidance. And I guess I'll add, we have updated the county manual with some additional guidance on how to use the USLE and tried to actually, removing the county USLE and only using the state USLE, it's actually we hope to simplify the process and make it more cohesive with the state. So with that, when we updated the manual, we kept the state's guidance in mind, and there shouldn't be much difference between the two guidances now, again, besides the 33% max versus the state's 20%.
I can add that I think if you're not sure of which one to use the county. If you're designing a site that the county, as in our division, is reviewing, and you're not sure, well, looks like the state wants something else, look to the manual, because our wiki page will say, if it's win, lose, or draw, we want you to use the county standard.
And if there are big differences that, you have concerns about, just shoot one of us an email and we can address it. There's another good question here. Many times when filling out the USLE and submitting the permit, the actual start date is not known. If the start date slides, but the permit still expires based on the USLE, how should this be handled? And I think Casey talked about if a start date's not known, you can always use the May 15th date, right, Casey? That's kind of the beginning of that worst case scenario where the storm and the erosion is highest. So if you can meet it with that start date, you should be able to meet it with any other start date, really. But the issue of the permit expiring on the end date of the USLE, and if your construction goes longer than that, we would hope that you as the designer or the contractor is aware of what's going on the site. And if something is going to go beyond that end date, you would be needing to submit a revised USLE, right, with an accurate schedule. And we hope that you kind of do that anyway as the construction is progressing and as the site's being developed. If it's not being developed in line with the schedule or the USLE, we expect you to submit a revision so that we're aware of what's going on the site. Because a lot of the county inspectors are only out there once a month. So they certainly don't always know what's going on out there. And I guess along those lines, if you make your USLE schedule so tight that you're right at the maximum soil loss and you then go over your schedule, well, yeah, you're over your soil loss, and we would essentially make you take immediate action to try to be reducing that soil, since you're now essentially out of compliance with the ordinance. So I guess that's answer to that question. A couple more.
Could I just add to that? I would, if you're revising the plan and the start date slipped, with that new USLE, just make sure that you put the new start date on and let us know, because that gives you back that time that you can use. And I think the date is May 16th, as the same person had mentioned a little further down. So yeah, the 16th, you could use that as the start date. The July case that I mentioned, that is for a short project. We're not talking about like a large construction project. The 2-week time frame in July would be if you have a small project that you could get done and just don't know when exactly it's going to take place.
Looks like Jess would like to answer the driveway question.
Oh, sure.
Yeah, so if you have a driveway project, it says for driveway projects, will the end date be when the driveway is paved, gravel finalized, or when the side slopes are fully stabilized and established? So I would be asking to see 2 different soil loss equations for that scenario. And your permit, I'm wondering if maybe the end, there's 2 different ways to think about it. You have your permit expiring, so stabilization, and then you have your end date. For the soil loss equation, your end date for the side slopes is going to be when you put your seed and mulch down plus 60 days, and that gives you your end date for the soil loss equation. But the timeline for that side slope would be expiring on that date you put your seed and mulch down or erosion mat. On the other hand, the driveway paved surface, the driving surface, the end date for that would be the date you put your pavement or your top course of gravel on it. And so that's going to be a different timeline. And then your permit would expire on the stabilization date, which may be the same as your end date. Overall, the permit for that site would be expiring on your last USLE stabilization.
Yeah, there's another good question here talking about, the maximum slopes allowed through the USLE. What about areas of the site that go over that 33% in the county? Well, in that case, again, you can go back to the DNR prescriptive compliance. There's a lot of good information in there on how to handle those slopes. And a lot of it comes down to, well, if you have slopes that are over the allowable, you can't model it, you should be getting those areas stabilized very quickly after disturbance. I mean, that's kind of rule number one. Because, you know, if it's not going to be sheet and rill erosion off of those areas because it's so steep, you're going to be having a lot of erosion and it needs to be getting stabilized. But I would, again, direct you back to the DNR guidance on prescriptive compliance. And again, in your plan, it's a good idea to call out those areas of your site that require that prescriptive compliance so that your contractor knows that these are critical areas and they should be getting stabilized as soon as possible after they're at final grade, or immediately after getting final grade, really.
I agree, Elliot. I also wanted to just add a thought there that, you know, the USLE could still be a useful tool to characterize that site somewhat, even if it does exceed the 3-to-1 side slope. You know, you still could model it and get a number, get a sense for how bad that is for the time frame that's being proposed. And although the number you wouldn't want to exceed the you know, you're not going to model it with more than the 3-to-1 slope, you still do get some information there. And we all know that it's going to be even worse, provided that it's steeper than 3-to-1. So at least it gives you some kind of a sense for what the time frame and the urgency is associated with something greater than a 3-to-1 slope.
And this is an interesting question here. Is there a weighted average approach to the site calculations? If there are areas of your site where you're retaining more than 5 tons per acre, you know, can that offset other areas of site that are exceeding the 5 tons per acre? The cool thing about this is that you can have as many USLEs as you want, right? When you model a slope on your site using the USLE, and you choose practices that will get you within the allowable, that you're essentially saying, well, all of my site has to have that practice. If you wanted to model some shallower areas of your site with some different slopes, and those areas you only have to, you know, do a lesser practice, you can do a lesser practice. That's why we recommend that you do multiple slopes across your site so that you can determine what practices are necessary to keep those areas of your site within the 5 tons per acre standard. So yeah, you can do one USLE for your whole site, but you're effectively saying, well, then whatever practice I need for that slope, I'm going to need it everywhere on my site, which usually isn't the best engineering approach if you're trying to reduce costs and you know, design your site critically. So
I like to use the whack-a-mole analogy. So if a certain area of the site is more challenging than another, you treat it appropriately for the time frame that's being proposed, and then what becomes the next most challenging part of that site. And so you continue to work your way down that ladder of challenging aspects on the site until ultimately none of them become a limiting factor anymore for the schedule that's being proposed.
Yeah, I was going to mention this anyways, Jim, is the mindset that we're trying to change is that currently, you know, we are a little bit more strict probably with plan review. And we're also a little bit stricter on site. So we're going to ask that the temporary stabilization is actually followed. We're going to ask that if your plan calls for multiple mobilizations for your landscaper or your excavator, that happens. So if that's something that needs to be done, you may need to remind the contractor, hey, I'm calling for, or the county, you know, requires temporary stabilization. So we're going to need you to be out there more often, and then build that into the plan and build it into the budget.
Well, we're at 1 o'clock, and there's a few questions that we didn't get answered, but we can definitely follow up with those. We really appreciate all of your attendance and the good questions, and please do let us know if you're interested in additional webinars from the county, even if it is even another follow-up of the USLE. It seems like a simple thing, but I know that there's a lot of different cases, and sometimes it's not very straightforward. So thank you for attending today, and we will follow up with those who requested PDHs with an email certificate. Thank you.